This is Math 131, section 3.4. We're going to start by talking about what the concept of equivalent statements. Okay, so we say statements are equivalent. We use this symbol, this kind of double arrow with a double, bar in between, or we can just use like an equal sign with 3 equals instead of 2. Okay, so we say two statements are equivalent, so either one of those works. But if both statements have exactly the same truth values I added all of the answer columns of the truth table. So the answer columns for the truth table have to be the same for each possible case for two statements to be equivalent. So by the converse of that, it says if the answer columns are not identical, then the statements are not equivalent. Okay. So when we talk about equivalent statements, sometimes we use the words logically equivalent or equivalent. So those mean the same thing if the statements are the same. Okay. Okay, so let's look at our first example. We're going to see whether these two statements are equivalent. We have P and Q or R in parentheses, and then we have P and Q and P and R. Okay, so we have these P and Q in parentheses and P and R in parentheses. So we're going to have to get a truth table for both of these and see if they're the same for each possible combination. Okay, so here is the our truth table. Remember, we set up the P's. When we're doing 3 simple statements, we're going to have 8 lines. So we're going to do 4 T's and 4 F's for P. Then we're going to do 2 and 2 and 2 and 2 for Q. So 2 T's, 2 F's, 2 T's, 2 F's. And then just true, false back and forth on the R. TF, 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 TF. Okay. So that's how we set up our table with the 3 simple statements. We're going to do P and Q or R. So we have to do parentheses first. So we're going to do Q or R first. That will be our first step. Well, technically the first step here is to carry the P over, but that's fine. We can, do that if you want. Okay. So Q or R, remember, just has to be one true. So true or true gives us true. True or false gives us true. False or true gives us true. False or false, false. True or true, true. True or false, true. False or true, true. And false or false, false, false. Remember with false or false, false. So remember with Q, with or, we just need 1 T, okay, or 2. Okay. So now we're going to take the P and that Q or R. Okay. So remember we have to have 2 trues for and to be true. So we have 2 T's, that's true. 2 T's, it's true. 2 T's, true. Only 1 T, false. Only 1 T, false. 1 T, false. 1 T, false. No T's, false. Okay. So that's that third step is the first simple statement. We've done all the parts for that. Okay. Now let's do the second statement. Okay. So we have P and Q or P and R. So we have to do the parentheses first. So we'll do this as our first step. This P and Q. 2 trues gives us a true. 2 trues, true. Remember, and we need 2 trues, so we only have true, false there. So that's false. True, false gives us false. False, true gives us false. False, true gives us false. False, false gives us false, and false, false gives us false. Okay, so there's a P and Q. Now let's look at P and R. Okay, P and R, 2 trues, true. True, false gives us false. True, true gives us a true. True, false gives us a false. False, true, false. False, false, false. False, true gives us false. And then false, false gives us a false again. Okay, so now we have P and R. Now we're going to take the or of these two. Okay, this P and Q and P and R. Okay, so now remember we just need 1 true. So we have 2 trues there, so true. We have 1 true, so that's true. 1 true, so true. No trues, so that's false. No trues, no trues, no trues, and no trues. Okay, so here's our second complex statement that we did is this other violet column. Okay, so now we just compare them, see if they're the same. True, 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 false, 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 false. So we see that those are equivalent statements, that they're the same for every possible combination. Okay, and because we said that that this statement is equivalent to this statement. Okay, so we have that little double arrow thing. Okay, that means those are equivalent statements. They're true for any possible combinations of P, Q, and R truth values. Let's look at another example using words statements. So determine which statement is logically equivalent or equivalent statement to it is not true that the tire is both out of balance and flat. Okay. And then one statement would be if the tire is not flat, then the tire is not out of balance. B would be if the tire is not out of balance or the tire is not flat. C would be the tire is not flat and the tire is not out of balance. And D would be if the tire is not out of balance and the tire is not flat. Now we're going to use simple statements. We're going to have one simple statement would be the tire is flat. Remember, there's no not there. And then the other statement would be the tire is out of balance. So we're not going to we'll save the nots for our negations. Okay, so remember our simple statement should not have a not in them. They should be just the tire is flat or the tire is out of balance. So we'll use P as the tire is out of balance and Q as the tire is flat. Okay, so let's look at that first simple statement. It is not true that. Now when you see this part, it is not true that, you can kind of save that for last because it's negating everything that's after it. Okay, so we're going to think of like you could put a comma there sort of to mark it off, but we're going to put this statement in parentheses and then negate it. Okay, so the tire is both out of balance and flat, so that would be P and Q, and then we put parentheses and then we do the negation. It is not true that. Okay, because it is not true that implies that everything after that is what's false. Oops, don't want to do that. Everything that's after that is false. So so this thing in blue is we're going to put in parentheses and then we're going to negate what's in front of it. So that's why we have the negation in front of that. Okay. Okay. All right. This if then if the tire is not flat, negation Q, then the tire is not out of balance. Okay. So that's an if then. We have negation Q, negation P. Tire is not flat, tire is not out of balance. So we're going to look at the truth tables of those. So this was our first statement given, and this is A right here. I'll put a little A next to it. Okay. So this is A, just translating. And now we'll do B, C, and D and translate. Okay, remember this is our simple statement again. P, the tire is out of balance, and Q, the tire is flat. Okay, so B is the tire is not out of balance or the tire is not flat. Okay, so tire is not out of balance would be negation P. The tire is not flat would be negation Q, and we're saying or in between. So that would be our B statement there, translated. Okay, and then C would be the tire is not flat, negation Q, and the tire is not out of balance. So and negation P. Okay, so this is C. Okay. And then finally D was if the tire is not out of balance, then the tire is not flat. Okay, so that would be negation P, single arrow, if then, tire is not flat, negation Q. Okay, so this would be D here. Okay, so now what we're going to do is we're going to construct truth tables for all 5 statements and see which ones match. Okay, so we have to do all 5 kind of in a row. Okay, now because we only have 2 simple statements, we're just going to have 4 lines. So we set up our truth table as TTFF for P, and then TFTF for Q. And then our first statement that we were looking at was negation P and Q parentheses. Okay, so here we're taking the kind of the shorthand method. We're carrying P over, we're carrying Q over here, and then we're taking the and. So that goes under the and sign. So remember, 2 T's gives us a true, 1 T gives us a false, 1 T false, 2 F's gives us false. Okay, remember they both have to be true for an and. Okay, now we just negate this and. So that's the shaded column here. So TFFF becomes FTTT. Okay, so that's the one that we're comparing to all the other 4. Okay, so here's our A that we translated. Negation Q, if negation Q, then negation P. So we're going to carry negation Q over, or put negation Q down here. So TFTF for Q would become FTFT for negation Q. And then TTFF for P would be FFTT for negation P. Okay, now we're taking an if then. Remember, the only thing that gives us a false is a true false. So false false gives us a true, true false gives us false, false true gives us a true, and then true true gives us a true. So there's the truth values for that A. Okay, now we go to B. Again, we're carrying over negation P first, and then negation Q over here. So FFTT for negation P, FTFT for negation Q, and we're taking an or. So remember, we just have to have one true to be true. No true, so that's false. One true, so it's true. One true, so it's true. And then both true, it's true. Okay. All right, now we're doing the same thing, kind of the same negation Q, negation P we had in part A. So FTFT for negation Q, FFTT for negation P. We're taking the and. So F and F. Remember, we have to have two trues to be true. So that's false. T and F would be false. F and T would be false. And then T and T would be T. So that's the only one that gives us a true. Okay. And then finally, we're doing if negation P, then negation Q. So negation P, again, is carried over. FFTT. Negation Q is FTFT. If then, remember, the only thing that gives a false is TF. So FF is true. FT is true. TF is false, and then TT is true. Okay, now we want to see which of these are equivalent to this. Okay, so we have FTTT, okay, and the only one that's equivalent is B. Okay, so that would be the one that's equivalent. Say B is the one that's equivalent. Oops, let's do a different color there. Let's do it in blue. Okay, so B is the one that's equivalent, and the others are not. So we'll cross those off. Okay. See, we're comparing it to our first statement, FTTTs. So we can say negation P and Q is logically equivalent to that B statement, negation P or negation Q. So we can say that first statement given, it is not true that the tire is both out of balance and flat, is logically equivalent to the tire is not out of balance or the tire is not flat, which was the B statement there. Okay. Okay, if you remember De Morgan's laws for sets, remember we had A and B complement equals A complement or B complement. Remember, we kind of distribute the complement on the A and the B, and then we change this to the opposite. Okay, and if we have A or B complement in parentheses, we do the same thing. So we just take A complement, B complement, and then put an and in between without the parentheses. So we kind of change everything. We change this to the complement, this from or to and this from B to B complement. Okay, so remember we did that for sets. Well, it's the same idea for logic. So now we have the negation in front instead of after as that complement. So the it's the same idea though, but that we're taking the negation and putting it in front. We're talking about logic statements. So negation of P and Q is equivalent to, remember we're talking about statements now, so we use this instead of equals. Negation P or negation Q. So we negate the P, negate the Q, and change that and to an or. Okay, and then if we have negation P or Q, that's equivalent to negation P, so we negate the P, negate the Q, and then we change the or to an and. Okay, so you can kind of think of it like distributing. We're sort of distributing the negation here, and then the negation here makes this the opposite, and the negation here makes negation Q, and then this, so that's how we get negation P or negation Q. Okay, and the same idea here. So negation P and negation Q without the parentheses. So those are De Morgan's laws for logic. Okay, so let's look at a written example using written statements. Write a statement that is logically equivalent to, it is not true that tomatoes are poisonous or eating peppers cures the common cold. Remember, our simple statements should not have a not in them. So we could say one simple statement would be that tomatoes are poisonous, and one would be eating peppers cures the common cold would be another simple statement. So let's set it up that way. So P is tomatoes are poisonous. Q is eating peppers cures the common cold. Okay, and then this, remember, this is not true that kind of marks off the rest of it. Okay. So this statement behind it gets put in parentheses. Okay, and then we negate everything in front. Okay, so we have this statement: tomatoes are poisonous or eating peppers cures the common cold. So that's P or Q, based on how we define them, and then we put parentheses, and then we put the negation in front to take care of that it is not true that. So remember, when you see it is not true that, it's negating everything after that, so we have to use parentheses. We can kind of think of that as like that's a grouping symbol, you know, that groups everything after it. Okay, so here was our statement. It is not true that, you know, those two statements, or or those two statements, and by De Morgan's laws, we can say that negation of P or Q in parentheses is negation P and negation Q without parentheses. Okay, so we can say our equivalent statement is tomatoes are not poisonous, negation P, and eating peppers does not cure the common cold. Okay. In general, yes, that's true. We know that eating peppers does not cure the common cold, and tomatoes are generally not poisonous unless they're rotten or something. Okay, we can also take our conditional statement, our if-then, and write it as a disjunction or an or. Okay, so we can turn it into an or. Okay, so what we can say is if P then Q is the same as saying either not P or Q. Okay, so let's think in words again to our statement we talked about with the exam thing. So I would say if you pass exam 2, then you'll pass the class. That would be the same thing as saying either you're going to fail exam 2, okay, which means you won't pass the class, or you will pass the class, okay. So one of those things will happen, okay. Either you'll fail exam 2 or you'll pass the class. Because think about if you fail exam 2, then you might pass the class or not. Doesn't matter, right? But that already happened, okay. And then the other case would be, well, what about when you pass exam 2? Well, I already said if you pass exam 2 that you would have to pass the class, so that would have to happen. So we can kind of think of this logically. It's a little complex when we think of that logically as in words, but you can think of it this way: you're just negating that and putting an or instead there. Okay, so you're negating the first part and then putting an or in between. Okay, so to change a conditional statement into a disjunction, okay, negate the antecedent, okay, which is the thing before, that's the first part, that's the if part, and change the conditional symbol to a disjunction or an or symbol, okay, and keep the then part, the consequent, the same. Remember, this is our antecedent is, let me point that out. Antecedent is the P, it's the for part, and the consequent is the then, is the Q there, okay? So that would be the consequent. Okay, so let's look at an example where we're rewriting a disjunction as a conditional. We're kind of going backwards. So the cows are in the pasture or the horses are not in the barn. Okay, so the cows are not in the pasture or the horses are not in the barn. That would be using simple statements with a negation on one of those. Remember that our simple statement should be affirmative. They shouldn't have a not in them. So let P be the cows are in the pasture, and then the horses, Q be the horses are in the barn. Okay. So when we translate, we say the cows are in the pasture, P, or, that V there, the horses are not in the barn would be negation Q. Okay. Now remember, we can change this to, if you think about what we're doing when we go, remember we go from, let's say we go, I'm going to write it like this, A arrow B goes to negation A or B. So remember that these are the same, right? So these are equivalent statements. Okay, so what we can do is kind of go backwards and say, okay, let's negate this and then put an if-then in between. You know, kind of, because if you negate this twice, it goes back to where it started, right? So we could write this as this. Negation P, negate the first part, and then just change it to an arrow. And then don't do anything to the second part. Okay, so that would be the equivalent way to write that, where we're just negating the first part and then changing this to an arrow. And then we can go backwards and do the same thing. Negate this, change it to P, and change that arrow to an or. So it works both ways when we do that. Okay, so we negate the first statement, that P, okay, and then change the disjunction, the or, to a conditional. Okay, and then just keep the second statement the same. Okay, so we go to negation. We go from P or negation Q to negation P, arrow negation Q. Remember, we don't change that consequent, that second part. We only change the first part. Okay. So how does that translate? If the cows are not in the pasture, then negation P, then the horses are not in the barn. Okay, now we're going to talk about how the negation of the conditional statement can be written as a conjunction, as an and. Okay, this is a little bit more complicated, but you kind of think about, I kind of will show you how this came about. This was our original thing, writing our conditional statement as an or, as a disjunction, right? Remember, we changed the P to the opposite and then put an or there instead. Okay, so this is our first kind of what we had before, right? So that'll be our first step. Now what I'm going to do is negate both sides. So I'm going to put a negation on both sides of these. And you could do that, right? If this was true equals true, then this would be false equals false. They're the same, right? So now I'm going to negate the P, if P then Q. I'm going to negate this side. Now using De Morgan's laws for this, Remember De Morgan's laws say you can negate this thing, negate that thing, and change that to an and. Okay, so when I negate negation P, I get back to P. So that's like a double negative. Okay, and then this becomes an and then negation Q is negation Q. So I have this on the same side. Okay, and then I don't change this. This is just negation P, if P then Q, right? So that's how we get. That's the same thing right here. That's how we get that negative conditional statement written as a conjunction. So we kind of can derive it from this just by taking the negation of both sides. Okay, but the idea is that if we have a negation of an if then, is the same as saying P and negation Q. Okay, so let's look at a written example. Write a statement that is equivalent to it is false that if you hang the picture then it will be crooked. So remember when you see it as false that, we kind of mark off the things after that. So this is going to be a conditional. If you hang the picture then it will be crooked. And then we put the negation in front of that after we do parentheses around the conditional. Okay, so let P be you hang the picture, okay, and Q will be the picture will be crooked. Remember, we don't put knots in our simple statements. So it is false that, remember we'll mark this off, okay, so it is false that if you hang the picture then it will be crooked. So we'll do P arrow Q first, then put parentheses, and then do the negation for it is false that. Okay. Now, remember we said it's equivalent to, now they're using the triple equals. Remember that's the same as the arrows though, so they're just changing the notation. So, but it means the same thing, which is equivalent to P and negation Q. So remember this was our original. We said writing this in this way, you have negation of a conditional. Okay, that's equivalent to, I'm going to use triple equals as well. P and negation Q. Okay. So we're just showing that for this particular example. Okay, so it is false that if you hang the picture then it will be crooked is this, and then that's equivalent to you hang the picture and the picture will not be crooked. Okay, which is P and negation Q. Okay, so now we're going to talk about some kind of terminology based on conditional statements. We'll talk about the converse of the conditional, the inverse of the conditional, and the contrapositive of the conditional. So we'll define those in the next few slides. Okay, so we start with our regular conditional, which is just P arrow Q, and remember that means if P then Q. Okay, the converse says this, just going backwards. If Q then P. Okay. The inverse just changes the P and the Q to negation. So this would be if not P, then not Q. So we don't change the order, we just change them, both of them to the opposite. Okay. And then the contrapositive is we do both. So the contrapositive is we switch the order and we make them both the opposite. Okay. So contrapositive would be if not Q, then not P. Okay. So if you can think of converse as just switching the order, inverse as negating both statements, and the contrapositive is doing both of those things. Okay, so let's look at an example with written simple statements. For the conditional statement, if the painting is by Andy Warhol, that will be one of our simple statements. Then the painting is valuable. That will be our other simple statement. And we want to write the converse, the inverse, and the contrapositive for those. Okay, so let's start by saying P represents the painting is by Andy Warhol. Q is the painting is valuable. Okay, so our simple if then is just P arrow Q. Okay, and our converse is we just switch them. So we have Q arrow P, which says now if the painting is valuable, then the painting is by Andy Warhol. Okay. The inverse keeps the order the same, but we're going to change P and Q to the opposite. So this would say so we have instead of P arrow Q, we have negation P arrow negation Q. So if the painting is not by Andy Warhol, then the painting is not valuable is how we translate this, the inverse statement. And then finally, the contrapositive, we do both. We switch the order and we negate both of these. Okay. So P arrow Q, if P then Q, becomes if not Q, then not P. Okay, so that would be translated as if the painting is not valuable, negation Q, then the painting is not by Andy Warhol, negation P. Okay, so that we're doing both, switching the order and changing the negation of both. It's important to note, let's say we have this. Let's say we have negation P arrow Q. and I want to take the contrapositive. Now, when we switch the truth value of these, negate both of these, okay? So if I want to negate both of these, this becomes just P, because I already have negation P, and then this becomes negation Q. So the contrapositive for this one, I'll just write this contra. Positive for that one is this. I switch the order, and I negate both of them. So negation Q, arrow, now this just becomes P. See, because I'm negating both of these, and if I negate the Q, I get negation Q, but if I negate the negation P, I get back to P again. Okay. So when you already have a negation in your original conditional, you're just going to, when you change it to the opposite, you just take the negation away. So that's worth noting that when we do that, we change the truth value. Okay, kind of long, some long slides, but that's it for section 3.4. This will be included on test 2, so just keep that in mind.